please. Eyes up now. Eyes up. Time to work.
Okay.
Which one, miss?
1 second. Okay. Number. I 2. Number 12. Yep.
This right here? -1/2?
Yeah.
All right.
Oh yeah, that was my question.
So very, very, very good, guys. All right. So I didn't do a very good job because I didn't see that fraction there. So again, we'll just talk about it real quick. X, Y. Now, what numbers did I say to put in? Yeah, -202. The problem with that is that when you get a whole number, then you're adding a fraction. You see what I'm saying? So now I'm trying to get you to think about it for a second, right? So if I add 1/2 and 3/2, that'll work out to 4/2, which would be 2. Do you agree with me? So again, this won't be on the test, so it's not really that big a deal. I would go ahead and do -1, 0, and 1 this time. All right, let me show you why. Just erase it and you'll see why. If I plug -1 in, come on now, guys. We got fractions we're working on. If I plug -1 in, what's -1/2 times -1?
1/2.
1/2. 1/2 plus 3/2 is 2, which is 4/2, right? And 4/2 is the same as 2. Does everybody agree with that?
Yeah.
So I want you to go ahead and put -1, 2 down. And if I plug in 0, I just get the fraction what?
3/2.
3/2. And now if I plug in 1, I get -1/2
You get
plus 3/2, which is 1. Does everybody see that?
Wait, how is it? How do you graph that?
Plug 1 in.
How is
So if you plug 1 in, you get -1/2 plus 3/2. What's -1/2 plus 3/2? 2/2. What's -1 plus 3?
Oh.
Okay, so now let's plot those points. -1, 2. -1, 2 is here. Now, 3/2 is the same as 1.5. Right? 3 divided by 2 is 1.5. So 0, 1.5 would be right in the middle. And then over 1, up 1. And now you're drawing your fraction, or you're drawing your line.
I keep getting so confused by like when the symbols, like with the negatives, like where it is. Like it's so confusing sometimes.
You got to be careful.
Negative.
Right? Notice that's not a vertical line. What else? 15. Now, in this case, what am I going to make the x's? Nope. Nope. Why am I making them -3? Yeah, because that'll cancel out, right? That will cancel out, right? So if I say 2/3 times -3 minus 2, who can tell me what that is? Come on, please, someone tell me. Come on, guys. -4, right? So let's review that, because you guys, that was too slow. Look up, look up. Everybody's got to look up.
I was about to say -6. But...
Well, let's look at it and see why. All right? It's 2/3 times -3/1. What can I do to the 3's? They cancel out. That's why I chose 3. Right? So this cancels. So it's just -2. And -2 minus 2 is? -4. Now I have to plug in 0. What's 2/3 times 0? 0 minus 2. Negative 2. Now I'm going to plug in 3. Come on now, instead of this being a negative, it's just a positive 3. So everybody together, tell me what that's going to be.
0.
Who thinks 0? All right, darn, you guys were right. All right. Very good. So now graph negative 3, negative 4. Now watch me do negative 3, negative 4, Colin. Left 3. 1, 2, 3. Down 4. 1, 2, 3, 4. See that point right there?
Yeah.
Be careful with the negatives.
Yeah, because I know like double negatives will go like that in that area. Correct. And then like
0,
we'll
negative
just, like,
2.
double positives will just go up there.
Mhm.
And then I just get confused, like which, like the symbols for what I'm looking for, like on the other two.
Remember, left and right first.
Yeah.
So if you go negative, you go left. Then you go positive, you go up. Positive, negative. It's going to go. All right, so 0, negative 2. Everybody can plot 0, negative 2. And then 3, 0. Everybody can plot that. Now let's draw our line. All right, is everybody with me? That's not too bad, right? Okay. All right. Now, listen, we need to get going. All right, so I want everybody to pull up 9.3 now. All right. Listen now. Everybody's got to pay attention now because nobody really knows this, I don't think. All right, because I didn't teach this to you in 5th grade or 6th grade. It's brand new. Algebra 1 stuff. All right. Constant rate of change and slope. Underline that. You're going to be talking about that for as long as you're taking math. You're going to be talking about slope. All right. And the slope is what makes the line. Look up, please, for a second. This slope right here is 0. When you ski on a mountain, do you want the slope to be 0?
No.
No, or else it'll be cross-country skiing, which is not very fun.
Yes, it is.
All right.
My dad did.
Okay. So yes, if I was going to ski, I would want to cross-country ski too. All right. But if you want a little challenge, what do you do to the slope?
90 degrees.
You push it up. Yeah. Some of you would try to. You're going to ski off of 90 degrees, right?
Yeah,
That's called free falling. That means breaking your legs and your neck. All right. No mountain has a ski of this. Yes, 85 would be something like that. All right. So listen, look right here now. All right, this slope. Look up, so I can show you something. The slope of the horizontal line is 0. All right. Now I'm increasing the slope. All right. So what makes the lines different? They're slopes. That's what makes the lines different. All right. Now, when you read numbers from left to right. So we say here, all right, you're going up the mountain. So that has a positive slope. And here you're going what? Down the mountain. So that has a what? Negative slope. So right here, listen to me. This slope right here is what? 0. This slope right here is what? Positive. And this slope right here is what?
Negative.
Now, Julia said something important. This slope right here is actually what we say undefined. That has no slope. You can't ski down that mountain. All right? So again, starts at 0 and goes to undefined. The greater the slope, and that's why I say it's easy to think about it in terms of mountains. The steeper the slope, the greater the slope is. All right? So keep that in mind. Yes. That's exactly right. Here we go. Now listen, one more thing about slopes. If I have a line, if I tell you the slope right there is, let's say 3, the slope of this line is always going to be what? regardless of where you are on the line. Is everybody hearing me? All right. So slopes are what change your line. All right. The greater the slope, the steeper the line. So bear with me on this. All right. So now there is a way to determine the numerical value of the slope. All right. There is a way to determine the numerical value of the slope. And we say slope. Listen now. I want everybody to make some notes here. Your slope is simply your rise. Wow. Your slope, let me write this down. Slope is equal to your rise over your run. How high did you go up and how far did you go over? That's generally how we interpret what slope is. All right? Now, the formula for rise over run, I want you to write this down too. It's going to be the change in y divided by your change in x. That's what I want you to say. Your rise is going to be the change in your y values divided by the change in your x values. All right, it's not bad at all. Now I'm going to give you a formula. All right. So here we go. We have 2 points. We say the 2 points are x1, y1 and x2, y2. Now, the 1s are called subscripts and the 2s are called subscripts. So bear with me. And it's just indicating that those are what? Different lines. Everybody hearing me? Those are different lines. All right? So the formula is change. Change is subtraction. So Connor, are you with me? Bless you. The change is y2 minus y1 over x2 minus x1. That's what needs to be there. All right, that's super, super, super important information. All right, you have to know that. So again, slope is a ratio of your y change over your x change. All right, now I really want you to stay and concentrate with me. All right, I'm going to look at question number 2 because it's a graph. I want to show you something. Now, all you have to do is put all your thoughts into looking up on the board. You don't have to write anything down. Just look because it's important that you understand what I'm saying now. All right? So what I'm going to do is I need everybody to watch. You're going to miss something important. Again, there's nothing more important than watching what I'm doing right now. All right? So I can teach you something. All right, I put a point here. Here's a point. These are points on the graph. Do you see that? Don't do that. Just pay attention, Colin. Don't write anything down. Your slope is your rise over your run. So now watch me. I'm going to go up. That is referred to as my what? That's my rise. And if I go this way, that's considered my what? That's considered my run. All right? Now, how much did I rise? No, I rose 6. Now, again, I'm agreeing with you. It's 1, but you have to look at the scale, right? So listen to me. Did everybody see I went up what? I went up 6, and I went to the right how many? 3, because I went from 6 to 9. Is everybody with me? Right? So my slope is technically what? My slope is 2. Everybody hearing me? The slope is 2. All right? The reason why it's misleading is because the rise here represents what? 6 units. The run here represents what? 3 units. Is everybody with me? All right? So now, what do you think the slope is now? Keep your eyes up. Here to here. What do you think the slope is going to be? What do you think it's going to be? 2. Exactly. Now you got to pay attention. Look up. Again, now I'm going to watch. Come on, stop writing and pay attention. Listen to me. We got lots of opportunities. I'm showing you. The most important thing is I can show you right now. Don't try to write anything down. Just concentrate on what I'm saying. The slope of this line is equal to 2. We just said that. Now, watch this. I'm going to ask you a question. So who's listening? If I pick this point right here, and I go from there to there, what's the slope going to be? 2. What if I do this? I'm going to blow up. What if I say this rise over this run? What's the slope going to be? 2. The point is, it doesn't matter what points you choose. The slope of that line is always going to be what? It's always going to be the same, which is 2. Now watch right here. One last time. If I calculate from here all the way to here, it better be what? 2. So now we're going to check. How much did I go up? 6, 12, 18, 24. And I went over 3, 6, 9, 12. 24 over 12 is what? 2. All right? 2. Is everybody with me? All right? Now, when you actually do the division, all right, when you actually do the division, all right, the 2 represents the change in, now what's the y value referring to? Allowance per what? Per year or age. Exactly. All right, is everybody with me on that? So what are they doing probably? They're probably increasing the kids' allowance every year that they grow. Does everybody agree? So like if you're 5, you get $5. If you're 6, you get $6. If you're 7, you get $7, and so on. Is everybody with me on that? All right. So this slope is going to be called 2. All right. So your slope is the change in allowance every what? Every year. That's what that means. All right. So now, for some strange reason, I don't have any idea why, slope, they give the letter M. Now I would say S, but I don't know why they chose M. Somebody smarter than me decided to make the slope, instead of writing slope, you're just going to write M equals what? M equals 2. Everybody with me on this?
Yes.
All right. So you found out how to figure out what the slope is given a graph. All right. So now let's go back to 1. All right. We're going to go back to 1. All right. Now, here we just have points. This is x1, y1. This is x2, y2. This is x3, y3. This is x4, y4. Does everybody agree we could name them like that? All right. Now I'm just simply trying to find the rate of change. All right. So slope is equal to y2 minus y1 over x2 minus x1. Let's find out. What's y2 minus y1? 4. Very nice work. What's x2 minus x1? 1. So the rate of change is what? 4. That's all there is to it. Now, guess what happens if I pick y4 minus y3 over x4 minus x3? I'm going to get the same what? Same answer. It doesn't matter what 2 points I pick. If it's a line, the slope will always be the same. Everybody hearing me? Very important. And again, guys, this is actually pretty hard. All right, hard information. But the reason why it's hard is people don't understand the terms. Everybody hear me? if you understand the terms, then guess what? It's very simple. All right, it's very simple. All right, so let's go ahead and look at number 3. Now, I like number 3 again because it's a graph. All right, so to find the rise over run, let's pick a point. Here and here. Doesn't matter what 2 points you pick. I just picked those 2. I want you to write M equals rise. How much did you go up?
1.
1. And your run is what?
20.
20. So your slope is?
20.
What's your slope? 1 over 20. 1 over 20. Anybody have a problem with that?
No.
Rise over run. All right. Now, once again, you can see if you chose different points, it doesn't matter. You're still going up 1 and over 20. All right. All right. Let's go to number 4. All right. Does it matter again? Somebody said 2. So I want you to write M equals 14 minus 10 over 4 minus 2. What's 14 minus 10? What's 4 minus 2? What's 4 divided by 2? Beautiful. All right.
Bless you.
All right. Anybody have any questions? All right. So now down here, guess what? They just gave us a bunch of points. All right. So again, guys, look right here. Here's what I want you to label it. You don't always have to do this, but here's how I want you to label it to start off. So this is considered x1, then this is y1. This is x2, and then that's what? y2. Does everybody hear me? So now underneath that, M equals y2 minus y1 over x2 minus x1 equals, what's y2? Now here's where people make a mistake. -7 minus what? -5. So there's a double negative, right? So I have to change it to what? Over. What's x2? -1, exactly. What's -7 plus 5?
-2.
What's 6 minus 1?
5.
So what's my slope?
-5. We never -2 over 5.
-2 over 5 is my slope. Is everybody with me on this? Everybody hearing me? All right, now look. Oh, how much time do we have?
7 minutes.
7 minutes, that's it? Okay, so here's what my deal is. All right, so let's not do the second page. But in order for us not to have to do the second page, I need you to write out the formula. All right, so every time you're doing this, every time you have to write the formula, you write M equals y2 minus y1 over x2 minus x1. Does everybody hear me? Now, listen, doesn't do any good to copy and paste it. All right? And like I said, it really doesn't bother me if you do that, honestly. I'm just trying to tell you the most effective way to learn. Copying and pasting is not an effective way to learn, even though I do it all the time. All right? Because it's quicker. It makes it more efficient. All right? So you're judging yourself. Do I know what the slope formula is? When you know what the slope formula is, you can paste it if you want. But hear me, I want you writing down the formula every time, and then you make the substitution. So this is what I want to see on your paper. All right? So then I would say what? What's y2? Bless you.
1.
1. Then minus what?
Negative.
Now, do you see what I'm emphasizing the double negatives? Does everybody agree? And then what's x2? Minus, what's x1? 7. So 1 minus -3 is really a what? So that would be 4 over 1. Is everybody happy with that explanation? Is everybody good? All right, let's do one more, and then I'm going to let you loose. All right? So m, again, equals y2 minus y1 over x2 minus x1 equals. So what's y2, somebody? 6 minus, what's y2? Over 12 minus 7. What's 6 minus 2? 4. 12 minus 7. So my slope is what? 4 over 5. Is everybody agreeing with me? That's not that bad, right? So that means you go up 4, and you're going to run what? 5. Is everybody happy with that explanation? All right. Does anybody need me to do any more?
No.
All right. So every single time, I want you to write m equals y2 minus y1 over x2 minus x1, and then show me that. All right. So the only thing you have to do is the first worksheet, not the second worksheet. I think that's fair enough. Does anybody have any questions? All right. Good job today, guys. Again, very good job.